the mention of antimatter, one of two thoughts may come into your head. The first being, never heard of it. The second being, oh yeah, isn't that like in sci-fi movies or something? Well, antimatter, strange as it sounds, is not just something thought up by movie producers to put into futuristic plots. It actually exists, though in very small amounts. Scientists today can create it routinely in laboratories. I chose this topic because I was both interested and confused by this bizarre concept. I am no longer confused, though, as I have been studying antimatter for months, reading books, interviewing professors, and watching videos. Now, in Star Trek, antimatter is used as rocket fuel. This is possible, but highly impractical. Good evening. My name is Tyler Bartlett, and tonight I will be discussing how antimatter is the opposite of matter, forms out of energy, and can return to energy through the process of annihilation. Now, most people learn in school that the world is made up of atoms, which are comprised of protons, neutrons, and electrons. While the electron is fundamental, the proton and the neutron can be broken down into smaller particles. Now, the standard model of particle physics describes the fundamental particles. According to this theory, there are 17 fundamental particles. 5 of these are force carrier particles, which carry 3 of the 4 fundamental forces, and the other 12 are matter particles. Now, of the 12 matter particles, 6 of them are quarks, which make up protons and neutrons, and feel the strong nuclear force. And the other 6 are leptons, such as the electron, that do not feel the strong nuclear force. Now, all of these matter particles have corresponding antiparticles. Now, these particle-antiparticle pairs are related with what are referred to as the 3 symmetries. Now, the first symmetry is time reversal. An antiparticle is mathematically equivalent to a matter particle traveling backwards in time. The second symmetry is charge conjugation. This states that all antiparticles have the opposite charge of their corresponding matter counterpart. Now, the third symmetry is parity, which in a general sense is just the reversal of coordinates. Now, in particle physics, parity is the reversal of the particle's spin. Now, spin is not literal spinning, but it is the angular momentum of the particle. Now, spin can either be left-handed or right-handed. Now, charge conjugation and parity are grouped together into one symmetry called charge parity, or CP symmetry. Now, CP symmetry states that a left-handed particle behaves the same as a right-handed antiparticle. Now, you still may be wondering why 2 symmetries are grouped into one. Well, the application of CP symmetry can be seen in the neutrino. Now, as I discuss in my written piece, the neutrino is a lepton that has no mass and no electric charge. The neutrino can only have a left-handed spin, and the antineutrino can only have a right-handed spin. The neutrino violates charge conjugation because flipping the charge of a neutrino would result in a left-handed antineutrino, which does not exist. And it also violates parity because flipping the spin of a neutrino would result in a right-handed neutrino, which also does not exist. However, if you flip both the charge and the spin of the neutrino, the result is the right-handed antineutrino, which is the correct particle. So, neutrino obeys CP symmetry, but it does not obey C or P symmetry. Now, earlier I briefly mentioned that 5 fundamental particles carry 3 of the 4 fundamental forces. Now, as you most likely already know, the photon carries the electromagnetic force. There is a particle known as the gluon that carries the strong nuclear force. This is the force that binds quarks together into protons and neutrons. The weak nuclear force is mediated by 2 very massive particles known as the W and Z bosons. The 5th force carrier is the Higgs boson, which carries the Higgs mechanism. Strangely enough, each of these force carriers can transform into one particle-antiparticle pair in an event known as pair production. Einstein's famous equation, E equals mc squared, describes this event. Now, E equals mc squared states that energy is equal to mass times the constant squared. This means that the energy required to create a particle-antiparticle pair is equal to the mass of the pair times the speed of light squared. Now, to put this in numbers, This energy is equal to the mass of the individual particles being annihilated, multiplied by 180 quintillion, or 180 with 15 more zeros after it. Now, since antiparticles have the same properties as their corresponding matter particles, with the exception of charge and spin, complex antiparticles can be formed from the fundamental antiparticles. Just as quarks can be combined into protons and neutrons, antiquarks can be combined into antiprotons and antineutrons. Now, these can be combined into an antinucleus. And if the antinucleus has an anti-electron or a positron placed in orbit around it, it becomes an antiatom. Now, there is also an atom which consists of both matter and antimatter. It has a matter nucleus orbited by an antiproton. I illustrate this atom as well as an antiatom and a normal atom in my model. Now, just as a force carrier can become a particle-antiparticle pair, a particle-antiparticle pair can become a force carrier. When matter and antimatter come into contact, they both disappear, leaving behind massive amounts of energy. This event is known as pair annihilation. Now, since an antiparticle is equivalent to a matter particle traveling backwards in time, pair annihilation can be seen as pair production running backwards in time, and vice versa. Now, just as with pair production, E equals mc squared applies to annihilation. Now, a lot of energy is released, or is required to produce antimatter. This same huge amount of energy is released in annihilation when mass is converted to energy. Now, this energy is 180 quintillion times the mass of each of the individual particles being annihilated. Now, to put this in perspective, if a paperclip-sized amount of antimatter were to annihilate, the resulting energy would be equivalent to that of a nuclear bomb, which is enough to power the space shuttle into orbit 20 times. Now, with the massive energy potential of antimatter, you may be wondering, well, why can't antimatter be used as rocket fuel? Well, here is another illustration. If all the antimatter ever created in laboratories on Earth was combined and annihilated, the resulting energy would be enough to heat up about 5 gallons of coffee. So we will not have a paperclip-sized amount of antimatter anytime in the near future. You must remember that to get the antimatter in the first place to annihilate and release the energy, you have to have the same amount of energy to create the antimatter. Now, in my study of antimatter, I have found significant evidence to support my creationist worldview. Now, according to the Big Bang Theory, there would have been equal amounts of matter and antimatter at the beginning of the universe. Now, theoretically, all of the matter and antimatter should have annihilated, leaving a very small amount of matter left over due to slight CP symmetry violation. However, we live in a matter universe with almost no antimatter. Now, there is a CP symmetry violation that we know of, but it is not big enough to allow for the vast difference in amount between matter and antimatter. This evidence helps support that in the beginning, God created the heavens and the earth, as it says in Genesis 1:1. In conclusion, antimatter is not science fiction, but science fact. Scientists today create it routinely in laboratories. Now, antiparticles are related to their matter particles with 3 symmetries. Any of the 5 force carriers can transform into one particle-antiparticle pair if it has a very high amount of energy. This same amount of energy is released when matter and antimatter combine in annihilations. So antimatter, the destroyer of matter, is real. I would like to thank God for helping me through this project. I would like to thank my parents for supporting me and helping me through the project. I would like to thank Dr. Haynes and Mrs. Shinzy for helping our class through the project. And I would also like to thank Dr. Aaron Pierce, Dr. Raymond Brock, and Dr. Tom Schwartz for allowing me to interview them. Thank you. Are there any questions?
Kate, why did you pick this topic?
Well,
Why did you blow us away?
I know.
Wow, I'd be amazed and anti-amazed at the quintillion at the same time. That makes sense. That was amazing. Simply amazing.
Well, why did I pick this topic? So, in the first semester, I had to do another science project, and my topic was nuclear fission. And in one of my books, I found the concept of antimatter, and I became very interested.
It's nice.
So that is how I picked antimatter as my
He's the next Bill
Dr.
Gates.
Haynes.
How did you keep everything straight, the quirks and the negatives
He
and
knew
the
it all
positives?
is, no
and-
doubt.
How did you do that?
How did you do that?
Did you have to visualize them in your head, or?
Well,
He's just.
I read about, I was reading about the quirks and stuff along back then, 'cause that was all I was in the book. So I was reading about that prior to doing this project.
So you had an idea, at least that part of it.
Yeah, yeah. Noel, what is
Why
it?
am I not in your thank yous?
You did not contribute to my project.
See, you're not as smart as we think you are.
Kind of.
That was great.
Walk us through your other model.
Okay, so this is the deuterium atom, consisting of a proton, a neutron, and an electron. It has the quarks inside of the proton and the neutron. And then this is the anti-deuterium atom, which has an antiproton, an antineutron, and a positron. And it consists of the antiquarks. And then this is the part matter, part antimatter atom that has a proton and a neutron orbited by an antiproton. So.
Certainly
Nine,
an ambitious topic, very well done.
9/19. Okay.
Thank you.